6 feet under your front yard right now, there's a temperature that never changes. Not in July, not in January. It just sits there. And there's a way to pull that temperature into your house and cool your air for almost nothing, using a setup that can cost as little as $300 in parts. So why have you never heard of this? Stick with me, because the reason is kind of messed up. Here's what we're getting into. First, I'm going to show you the actual science behind this, because this isn't some sketchy life hack. It's real physics that people have used for thousands of years. Then I'm going to show you that this isn't some fantasy idea. It's something people are doing right now, today, in real homes in Europe. And then I'm going to get into why this never really caught on in American homes, because that part is honestly the most interesting piece of this whole thing. Let's get into it. If you live somewhere hot, you know the feeling. You open your power bill in August and your stomach drops a little. $300, $400. And the worst part is you don't even feel like you're being wasteful. You're just trying to not sweat in your own living room. Your AC unit is working as hard as it can, but here's a number that most people never think about. Every air conditioner has something called a coefficient of performance, which is just a fancy way of saying how much cooling do you get for the electricity you put in. A normal home AC unit gets you somewhere between 2.5 to 3.5 units of cooling for every unit of power it uses. That's decent. That's why air conditioning changed the world. But it's not the best number out there, not even close. And the thing that beats it isn't some new invention. It's been sitting under the ground the entire time. Here's the actual science, and I promise this is simple. If you dig down about 6 to 10 feet almost anywhere, the soil stops caring what season it is. It holds steady at roughly the average yearly temperature for wherever you live. So if you're in Chicago, that's somewhere in the low 50s. If you're in Phoenix, it's warmer, but it's still way cooler than the surface in summer. The reason this happens comes down to something called thermal mass. Dirt is heavy. It takes a huge amount of energy to change its temperature, even a little bit. So when summer heat tries to soak down into the ground, it moves so slowly that by the time it gets 6 feet down, the season has already changed again. The ground basically acts like a buffer that smooths everything out. This is also why old root cellars kept vegetables cold for months without any power, and why wine caves stay at the perfect temperature year-round without a single machine running. Now here's where it gets interesting, because people figured this out a really long time ago, without any of our modern tools. About 2,400 years ago, in what's now central Iran, people built these massive dome structures called Yakshals. The word basically means ice pit. These weren't just holes in the ground. They were tall, beehive-shaped buildings, some of them 60 feet high, with walls that were over 6 feet thick at the base. And the material they used for those walls is honestly wild. It was a mix of sand, clay, lime, goat hair, and egg whites. And it worked so well as insulation that it's been compared to modern fiberglass. These yakshals were often built next to underground water channels called kanats, and sometimes they had tall wind towers attached that pulled cooler air down into the structure. But here's the part that really gets me. At night, in the middle of the desert, the sky is so clear and dry that heat from a shallow pool of water can radiate straight up into space, even when the air temperature is still above freezing. That's how they made ice, in the desert, with zero electricity. They'd let water sit out at night, it would freeze from losing heat to the open sky, and then they'd store that ice in these insulated domes, packed in straw, and it would last through summers that hit over 115 degrees. That's not a legend. That's documented, measured, and some of these structures are still standing today. And this wasn't just a Persian thing. Out in the American Southwest, native peoples were building homes partly dug into the ground for around 8,000 years, using that same basic idea: earth contact keeps you cooler. Different continent, different century, same physics. People all over the world kept landing on the same solution because the solution actually works. The Romans get brought into this conversation a lot, but let's be accurate about what they actually did, because it's still impressive. Wealthy Roman homes would run water straight from their aqueducts through pipes built into the walls, which cooled the rooms down as the water passed through. They also built homes around open courtyards with a shallow pool in the middle, which cooled the air through evaporation, plus shaded gardens that did the same thing with plants. It's basically an ancient version of a swamp cooler combined with smart architecture. So no electricity, no mechanical parts, just smart use of water and airflow. So if all of this has been figured out for thousands of years, why did it disappear? In 1902, a guy named Willis Carrier was working for a company in Buffalo, trying to solve a humidity problem at a printing plant in Brooklyn. The issue was that humid air was warping the paper and ruining the print quality. Carrier built a machine that could control both temperature and humidity using mechanical refrigeration, and that invention became the foundation of modern air conditioning. Within a few decades, air conditioning went from an industrial tool to something marketed straight to regular families, with big advertising pushes selling it as the symbol of modern comfort. And once millions of homes had mechanical cooling, the entire system around home building grew up around that assumption. Building codes, contractor training, licensing exams, all of it got built with the idea that cooling means a machine with a compressor and refrigerant, full stop. Nobody sat down one day and said, let's ban earth cooling. It just got left behind, because the entire industry, the entire education system for contractors, and the entire code structure had already locked itself around the mechanical version. And look, the HVAC industry isn't some made-up villain here either. It's a real, multi-billion-dollar industry, and like any industry, it spends real money making sure laws and codes work in its favor. The main trade group for air conditioning manufacturers in the US spends a bit over $1 million a year on federal lobbying. That's not some shocking secret number, that's public record. But you don't need a massive conspiracy to explain why a different, older technology doesn't get much attention. You just need an industry that has zero incentive to remind you it exists, codes that were never updated to include it, and 3 generations of contractors who were never even taught about it in school. Meanwhile, in Europe, this never actually went away. Earth tubes, sometimes called thermal labyrinths, are a real part of what's known as passive house construction in Germany and other parts of Europe. The idea is simple. You bury a smooth pipe in the ground, usually somewhere around 6 to 8 feet deep, below where the ground freezes in winter. Outside air gets pulled through that buried pipe before it ever enters the house. In summer, the air goes in hot and comes out noticeably cooler. In winter, it goes in freezing and comes out already warmed up a bit. One builder who actually installed one of these systems documented the whole thing, and the materials cost him under $2,000 total, which is genuinely cheap compared to a full mechanical cooling system, and a lot of that cost is just the pipe itself, which can run as low as a few $100s depending on length and material. Now let's talk real numbers, because I don't want to oversell this. A basic earth tube system on its own usually gets a coefficient of performance somewhere between 2 and 4. If you pair it with an actual ground source heat pump, that number jumps up to somewhere between 3 and 6. Compare that to your regular AC unit sitting outside your house at 2.5 to 3.5, and you can see it's a real improvement, just not some magic miracle number. It's a meaningful edge, especially because the only power it usually needs is a small fan, something in the range of 50 to 80 watts, which is less power than a hairdryer. There are real challenges too, and I'd be lying if I said this was a perfect plug-and-play solution. The biggest one is moisture. When hot, humid air drops in temperature inside that buried pipe, water condenses inside it. If that water just sits there, you get mold, which completely defeats the purpose. So any real system needs a slight slope, something like a 2% grade, so the water drains out instead of pooling. The other concern is radon, a naturally occurring gas that comes up from the ground in certain areas. It's a real risk, but it's also a manageable one. Adding an activated charcoal filter at the point where the air enters your home can cut radon levels down by a huge percentage, and that filter usually only costs you a few dollars a year to maintain. So here's the real picture, and it's actually more interesting than some hidden conspiracy. This is a genuine, physically proven way to pre-cool air using nothing but the ground beneath your feet. It's been used by ancient civilizations independently, on different continents, thousands of years apart. It's currently being used in homes across Europe right now, not as some fringe idea, but as a known piece of efficient home building. And it mostly disappeared from American homes, not because someone banned it, but because an entire century of building codes, contractor training, and industry habit formed around one single solution and never made room for anything else. The physics never stopped working. Nobody told the dirt under your yard that air conditioning was invented in 1902. If you want to see exactly how someone could actually build one of these step by step, I've got that breakdown waiting for you in the next video.